In this video, we will study about electromagnetic waves. If we talk about the prediction and discovery of electromagnetic waves, they were predicted by James Clerk Maxwell and later experimentally produced by Heinrich Hertz. Electromagnetic waves consist of oscillating energy and magnetic fields. Now, let's see how electric field is produced. A changing magnetic flux produces an electric field. Its formula is this. Here, E is the electric field, phi m is the change in magnetic flux, T is the change in time, and R is the radius or distance from the source. Talking about the generation of magnetic field, a changing electric flux produces a magnetic field. Its formula is this. Here, B is magnetic field, mu naught and epsilon naught is the permittivity of free space, which is a constant value. Del phi is the change in electric flux, T is the change in time, and R is the radius or distance from the source. If we talk about the speed of electromagnetic waves in vacuum, it can be calculated by this formula. The speed of electromagnetic waves in vacuum is equal to 3 into 10 raised to the power of 8 meters per second, and the frequency is about 10 raised to the power of 6 Hz, which depends upon wavelengths. Talking about the production of waves, in laboratory, electromagnetic waves are produced by oscillation of electrons. Its frequency is given by this formula. Here L is the inductance and C is the capacitance. Remember that the reception of electromagnetic waves is based on an LC circuit. The frequency of the circuit can be varied by changing the capacitance, allowing it to remove different frequencies of electromagnetic waves. Now let's discuss the modulation. Modulation is defined as the process of mixing the low frequency signal, which are sound signals, with high frequency radio waves. The wave that comes after modulation is known as modulated wave. Here I have two types of carrier waves. Then I have audio signals. This is the frequency modulated wave and this is the amplitude modulated wave. You can see that both these waves have audio signals modulated in them. The types of modulation includes amplitude modulation, frequency modulation, phase modulation. Let's see how the modulated waves are demodulated. To retrieve the original signal, modulated waves are demodulated by receiving sets like TVs or radios. This involves receiving where the modulated wave is captured, then rectifying it where the wave is processed to remove certain parts and simplify the signal, and then detecting where the original lower frequency signal is extracted. Detection occurs when the tuning circuit's frequency matches the transmitting circuit's frequency, creating electrical resonance. This allows the receiver to lock onto the signal and extract the information. Keep this in mind that frequency range of amplitude modulation signal is 540 kHz to 1600 kHz, and the frequency range of the frequency modulation signal is 88 MHz to 108 MHz. This is because the FM signal does not contain any noise signal as the AM does. That's all for this video.